And finally, we're asked to consider two processes. And I'll put them on the board here. Process one is what we just drew a picture of, HBr liquid going to HBr gas. It's a vaporization of hydrogen bromide. And process two is what we started to draw a picture of, and that would be HBr in the gas phase, separating and into H and Br. And chemists usually write these little dots there to show us that there are unpaired electrons, that this is what we might call a free radical. And you're asked for the signs of delta H, delta S, and delta G at 298 for each of those processes. So here, this represents overcoming those dipole-dipole and dispersion forces. So we have to put energy in. Delta H naught would be positive. In fact, specifically, we would call it the enthalpy of vaporization if we had to assign a name and a number to it. Delta S naught would also be positive, since the gas phase is less ordered or more disordered or more entropic than the liquid phase. And now delta G naught, well, it's delta H naught minus T delta S naught. So we've got a positive minus a positive, and it's going to depend on the temperature. We're asked for the delta G naught at 298. You can't really look at this and say, is it going to be positive or negative, but you do have some data, and the data is at the boiling point, the normal boiling point of hydrogen bromide is 207 kelvins. So because the boiling point is 207 kelvins, this will happen at any temperature, or this is spontaneous or thermodynamically favored, at any temperature above 207 kelvins. So at 298 kelvins, this process is spontaneously favored, and that would mean that delta G naught at 298 would be negative, less than 0. For process 2, the atomization of hydrogen bromide gas, splitting it into hydrogen atoms and bromine atoms, we would call this the bond dissociation energy, which would be much bigger than that, if that's the second part of this. But again, delta H naught would be positive, because we're putting energy in to break that bond. Delta S naught is positive. We've got 2 moles of gas phase particles that are more disordered than the 1 mole of gas phase particles. In this case, because this reaction, this does not happen spontaneously at 298 Kelvin, delta G naught 298 would also be positive. And then if we want to compare the values of delta H naught for these two processes, well, remember, this top process, this boiling vaporization, only requires us to break intermolecular forces. This requires us to break covalent bonds between the hydrogen atom and the bromine atom, and these are going to be much, much stronger. So the process 2 here would have a greater value of delta H. So I hope this helped you a little bit. Remember, don't try to memorize. Think about the models that we built and be familiar with them, and be very, very precise in your language. So good luck on the AP Chem exam, and I'll hope to see you again soon.